The judicious mix of these two modes of thought is central to the success of science. Good scientists do both. On their own, talking to themselves, they churn up many new ideas and criticize them systematically. Most of the ideas never make it to the outside world. Only those that pass a rigorous self-filtration make it out to be criticized by the rest of the scientific community. Because of this dogged mutual and self-criticism, and the proper reliance on experiment as the arbiter between contending hypotheses, many scientists tend to be diffident about describing their own sense of wonder at the dawning of a wild surmise. This is a pity, because these rare exultant moments demystify and humanize the scientific endeavor. Responsible, thoroughgoing, rigorous skepticism requires a hard-nosed habit of thought that takes practice and training to master. Credulity, I think a better word here is openness or wonder, does not come easily either. If we really are to be open to counterintuitive ideas in physics or social organization or anything else, we must grasp those ideas. It means nothing to be open to a proposition we don't understand. Both skepticism and wonder are skills that need honing and practice. Their harmonious marriage within the mind of every school child ought to be a principal goal of public education. I'd love to see such a domestic felicity portrayed in the media, television especially. A community of people really working the mix, full of wonder, generously open to every notion, dismissing nothing except for good reason, but at the same time, and as second nature, demanding stringent standards of evidence, and these standards applied with at least as much rigor to what they hold so dear as to what they are tempted to reject with impunity. Every now and then, I'm lucky enough to teach a kindergarten or first grade class. Many of these children are natural-born scientists, although heavy on the wonder side and light on skepticism. They're curious, intellectually vigorous. Provocative and insightful questions bubble out of them. They exhibit enormous enthusiasm. I'm asked follow-up questions. They've never heard of the notion of a dumb question. But when I talk to high school seniors, I find something different. They memorize facts. By and large, though, the joy of discovery, the life behind those facts, has gone out of them. They've lost much of the wonder and gained very little skepticism. They're worried about asking dumb questions. They're willing to accept inadequate answers. They don't pose follow-up questions. The room is awash with sidelong glances to judge, second by second, the approval of their peers. They come to class with their questions written out on pieces of paper, which they surreptitiously examine, waiting their turn and oblivious of whatever discussion their peers are at this moment engaged in. Something has happened between 1st and 12th grade, and it's not just puberty. I'd guess that it's partly peer pressure not to excel, except in sports, partly that the society teaches short-term gratification, partly the impression that science or mathematics won't buy you a sports car, partly that so little is expected of students, and partly that there are few rewards or role models for intelligent discussion of science and technology, or even for learning for its own sake. Those few who remain interested are vilified as nerds or geeks or grinds. But there's something else. I find many adults are put off when young children pose scientific questions. Why is the moon round? The children ask. Why is grass green? What is a dream? How deep can you dig a hole? When is the world's birthday? Why do we have toes? Too many teachers and parents answer with irritation or ridicule, or quickly move on to something else. What did you expect the moon to be? Square? Children soon recognize that somehow this kind of question annoys the grown-ups. A few more experiences like it, and another child has been lost to science. Why adults should pretend to omniscience before 6-year-olds, I can't for the life of me understand. What's wrong with admitting that we don't know something? Is our self-esteem so fragile? What's more, many of these questions go to deep issues in science, a few of which are not yet fully resolved. Why the moon is round has to do with the fact that gravity is a central force pulling towards the middle of any world, and with how strong rocks are. Grass is green because of the pigment chlorophyll, of course. We've all had that drummed into us by high school. But why do plants have chlorophyll? It seems foolish, since the sun puts out its peak energy in the yellow and green part of the spectrum. Why should plants all over the world reject sunlight in its most abundant wavelengths? Maybe it's a frozen accident from the ancient history of life on Earth. But there's something we still don't understand about why grass is green. There are many better responses than making the child feel that asking deep questions constitutes a social blunder. If we have an idea of the answer, we can try to explain. Even an incomplete attempt constitutes a reassurance and encouragement. If we have no idea of the answer, we can go to the encyclopedia. If we don't have an encyclopedia, we can take the child to the library. Or we might say, I don't know the answer. Maybe no one knows. Maybe when you grow up, you will be the first person to find out. There are naive questions, tedious questions, ill-phrased questions, questions put after inadequate self-criticism. But every question is a cry to understand the world. There is no such thing as a dumb question. Bright, curious children are a national and world resource. They need to be cared for, cherished, and encouraged. But mere encouragement isn't enough. We must also give them the essential tools to think with. It's official, reads one newspaper headline. We stink in science. In tests of average 17-year-olds in many world regions, the US ranked dead last in algebra. On identical tests, the US kids averaged 43% and their Japanese counterparts 78%. In my book, 78% is pretty good. It corresponds to a C+, or maybe even a B-. 43% is an F. In a chemistry test, students in only 2 of 13 nations did worse than the US. Britain, Singapore and Hong Kong were so high they were almost off scale, and 25% of Canadian 18-year-olds knew just as much chemistry as a select 1% of American high school seniors in their second chemistry course, and most of them in advanced placement programs. The best of 20 fifth-grade classrooms in Minneapolis was outpaced by every one of 20 classrooms in Sendai, Japan, and 19 out of 20 in Taipei, Taiwan. South Korean students were far ahead of American students in all aspects of mathematics and science, and 13-year-olds in British Columbia, in Western Canada, outpaced their US counterparts across the board. In some areas, they did better than the Koreans. Of the US kids, 22% say they dislike school. Only 8% of the Koreans do. Yet 2/3 of the Americans, but only 1/4 of the Koreans, say they are good at mathematics. 63% of American adults are unaware that the last dinosaur died before the first human arose. 75% do not know that antibiotics kill bacteria, but not viruses. 57% do not know that electrons are smaller than atoms. Polls show that something like half of American adults do not know that the Earth goes around the Sun and takes a year to do it. I can find in my undergraduate classes at Cornell University bright students who do not know that the stars rise and set at night, or even that the Sun is a star. Because of science fiction, the educational system, NASA, and the role that science plays in society, Americans have much more exposure to the Copernican insight than does the average human. A 1993 poll by the China Association of Science and Technology shows that, as in America, no more than half the people in China know that the Earth revolves around the Sun once a year. It may very well be, then, that more than 4.5 centuries after Copernicus, most people on Earth still think in their heart of hearts that our planet sits immobile at the center of the universe and that we are profoundly special. These are typical questions in scientific literacy. The results are appalling. But what do they measure? The memorization of authoritative pronouncements. What they should be asking is how we know that antibiotics discriminate between microbes, that electrons are smaller than atoms, that the Sun is a star which the Earth orbits once a year. Such questions are a much truer measure of public understanding of science, and the results of such tests would doubtless be more disheartening still. If you accept the literal truth of every word of the Bible, then the Earth must be flat. The same is true for the Quran. Pronouncing the Earth round then means you're an atheist. In 1993, the supreme religious authority of Saudi Arabia, Sheikh Abdel Aziz ibn Baz, issued an edict or fatwa declaring that the world is flat. Anyone of the round persuasion does not believe in God and should be punished.